What we are going to be looking at in this video is the process of defining the formulas for motion, or kinematics. Now, I'm going to do that without using calculus because I don't think you need to use calculus to define these formulas, and calculus can be a little bit confusing to some people, so I'm going to avoid using it. Consider the following object travelling from point A to point B with an initial velocity u and a final velocity v. If we had that situation, this is what we have. We've got a point A and a point B, something travelling with an initial velocity u, a certain displacement s, and finishing at a final velocity of v, and the time in which it took to get from point A to point B. Okay, so that's all that's showing is something travelling in an initial velocity over a particular distance or displacement, finishing at a final velocity, and the time in which it took to get between those 2 points. So S represents the displacement covered by the object, and T represents the time taken for the object to travel from point A to point B. Therefore, the average velocity can be expressed in two different ways, which I've listed here as equation 1 and 2. You would agree that the average velocity can be expressed as the displacement divided by the time. Likewise, if you have the final velocity and the initial velocity, if we divide it by 2, or if we add them together and divide by 2, we will also get the average velocity. So they are both rational equations showing the velocity, or the average velocity, for this situation up here. What I've done to equation 1 is I've rearranged then such that the displacement is on the left hand side of the equation. So I've just simply rearranged 1 to get 3. If I then substitute 2 into 3, it will give me this equation 4. So to get this equation 4, all I've done is I've substituted 2, which is this stuff, for the average velocity, into equation 3, which is right here. So where I have v ab, I'm going to substitute v plus u divided by 2, and that will give me this. Okay. We can also define an expression for acceleration. Now, we can rationally define that expression just by noting that, well, the acceleration of the object is going to be equal to the change in velocity divided by the time in which it took. And we can rearrange that to solve for t, or we can rearrange that to solve for the final velocity. Now, once again, this equation 6 and this equation 7, 6 and 7 are just rearrangements of equation 5. These are all essentially the same thing. It's just rearranging and showing a different subject. So on the left hand side I've got a v, I've got an a, and I've got a t, but these equations are all more or less the same. This here should look relatively familiar because this is one of our equations for motion, v equals u plus at, and it's probably the easiest one to come up with, which is why it's the first one we've seen. And I'm putting these equations in red boxes, so as you see them, they're going to be enclosed in a red box. Now, if I substitute this equation 6 back into equation 4, which if you look back is over here, equation 4. So if I substitute 6 into 4, it's going to give me a new equation, which I'm going to then call equation 8. So what I did was I substituted v take u divided by a into t. Okay, t is equal to v take u divided by a, so I can put this in place of t, which is why we've got this now. I'm going to have to go over the page because what I'm going to do to get equation 8, you'll note that I haven't actually called this equation 8, and that's because I can simplify this expression. Okay, we'll expand and simplify. So once I've got it simplified, then that will be my equation 8. But until then, I've got to go through the process of expanding and simplifying. So this is the process. Up the top, I've got a difference of 2 squares, and essentially I'm just simplifying to a point at which I cannot simplify nor factorise, and I'm calling that equation 8. Alright, so this here we've got a difference of 2 squares, which means that these two values here cancel out. A positive UV and a negative UV cancel straight out. Now if we rearrange to make v squared the subject from equation 8 and call it equation 9, we actually get this, which in a red box denotes one of the equations for motion, and it should look familiar. V squared equals u squared plus 2as. Okay, it is one of our equations for motion. So this one is the second one we've come up with, and I've just shown you how we go through the process of obtaining it. No calculus involved, it's just substituting into different equations. Another substitution. Now if I substitute 7, let's go back to what 7 was. We're going to have a look at what 7 was to do this. 7 into 4, so it's saying if we substitute 7 into 4, it's going to give us a new equation. If this is 9, we'll call it equation 10. So if we go back over the page and sub 7 into 4, here we have 7, and here we have 4. So if I substitute this into this, what's going to happen is I'm going to get, over the page, this here. Okay, so that is the substitution of 7, or equation 7 into equation 4, to give us this new equation here, which we're going to start simplifying. All I did here was put my two u's together to get 2u plus the at divided by 2. Further simplification. And if I actually expand this here, I get ut plus a half at squared. So this box, this red box, is actually the expanded version of this. Now this red box is another equation of motion. S equals the displacement, S equals ut plus a half at squared. You should have seen it before, it should look pretty familiar. Now the interesting thing is this can actually be factorised into this equation here. These two equations are the same. However, this is the one that we see as the equation of motion. Yet this one here is the factorised version. So this one is probably a little bit more simpler than this one here. However, this is the one that we do see commonly as one of the equations of motion. And that there is where I'm going to stop. What we essentially have found is 1, 2, 3 equations explaining motion, and those 3 equations, I'm telling you, they're the only 3 equations in which you need to define every other equation essentially. So once I get to that stage, I'm happy. I've shown that I've proven where this one comes from, how we obtain this one, v equals u plus at, and then going along the process or continuing on how we obtain this equation of motion, and then finally obtaining this equation of motion.